Okay, so I'm going to make a bit of a video clip to try and explain the pressure changes in the heart, because in the textbook it can be quite difficult. So if I break down sort of line by line, hopefully it'll make it a bit easier. And if you have any questions, please just email in or post on the Teams site so we can all see answers together. Right, so I'm going to put a rough sketch of the graph involved. So up here is the pressure changes of the heart. We're not going to add any numbers apart from some key ones later on. And along here is a time axis along the bottom. So what we need to take into account is the idea of the cardiac cycle. So you want to be thinking about atrial systole and ventricular systole, and also the diastole phases. So we'll label up those as we go. We also want to be thinking about what's happening with the valves, so which ones are open, which ones are closed, and where is the blood moving to. So this graph will show us all that information. Right, so we could start anywhere in the cycle, but we'll start with the atriums filling up. So what typically happens is we tend to look at the left-hand side of the heart, because the left-hand side of the heart has those dramatic pressure changes, say, when blood's leaving the left ventricle. And if you were to put, say, pressure monitors into the left atrium, the left ventricle, and then the aorta, this is the sort of the shape of the graph that you would see. So we'll start off by using, say, this pen to look at, say, the pressure changes in the atrium to begin. So as blood starts to enter the left atrium, we can see that it starts to fill up a little bit, and that chamber starts to fill up, so the pressure starts to go up a little bit. And as that occurs, blood starts to trickle into the left ventricle below it. So maybe I'll use this colour for the left ventricle. So the left ventricle, pressure starts to build up a little bit as blood starts to trickle from the left atrium to the left ventricle. As it starts to fill, we then have the left atrium will go through its contraction, so that will be our atrial systole. As those atrial walls start to contract, pressure increases and blood moves from the atrium into the ventricle. So a big sort of peak you see here. And then the atrial walls will relax, and as that occurs, you can see that dip down in the pressure in the atrium. So the next stage which will occur is that the atrial systole has occurred, so I can put on here atrial systole has occurred in this region here, and then we're now going to go into ventricular systole. So the ventricle walls will now, we're using red for ventricles, the red pen is going to be showing us the pressure changes in the ventricle. So ventricular systole will now occur, so those ventricle walls will now contract. And as blood moves out of that ventricle wall, it will push back on the atrium wall and close that atrioventricular valve. So you might see a little bit of a bump of increased pressure in the atrium as that occurs. So we've got a valve being closed here. So let's see if I can find let's use this pen. Say we have the atrioventricular valve that's closed. Valve is closed. Okay, so the first stage was atriums start to fill up with blood, atrial walls contract, and then blood's moved into the ventricle. So the ventricle walls are now going to contract. So as that occurs, you see this big increase in pressure, and blood starts moved out of the ventricle. So this now is ventricular systole. Now blood's going to move from the left ventricle into the aorta. So if the aorta was having a pressure roughly about, say, 80 millimetres of mercury at this stage, as the blood moves out of the ventricle, if it reaches the same pressure as the blood in the aorta, if it's slightly above this, it can open up that valve in the semilunar valve in the aorta. So then blood can move out of the ventricle as it goes through its final contraction into our aorta. So the aorta is being shown by this line here. So this big increase in pressure that changes when the ventricle walls contract and pushes blood into the aorta, reaching a pressure about 120, will make the blood move into the aorta, and it'll open that semilunar valve that we have here. semilunar valve, which is in the aorta. That one is open. So that will push that valve open as the pressure is greater than the aorta, and as blood moves into the aorta and the blood is moved away, the heart wall, the ventricle starts to relax, so that will fall right down back in the ventricles, and the aorta pressure stays high but starts to fall off as the ventricle contraction finishes, and then blood is gradually taken away by the aorta. Now, as the blood pressure in the aorta is higher than the ventricle, and the blood will fall back, and that will close that semilunar valve, which is in the aorta, will close. And as that closes, it causes a bit of a recoil in the aorta, and the aorta is very elastic because it's an artery. So this recoil that we actually have in the aorta is kind of our pulse that we can feel. It's been moved all the way through our arteries to get the blood to move around to various organs. So our aorta blood will stay quite high, stay about 80 as it gets taken away. So what we've got here is a few things you can see. You can see that the blood has been moved out of the ventricles into the aorta, and then the blood's now been taken away. We can also see the ventricle now is starting to relax. So we're going to a stage here where we actually have both parts of our heart are going into distally. So distally is kind of the situation where our heart is relaxed before the cycle begins again. So in terms of what was happening in the atriums, initially we had this contraction, then we had relaxation, and the blood was starting to fill up again. Still very relaxed at this stage, before our next peak would occur a little bit further on. So as our ventricles start to relax down here, so we're going to ventricular distally down here, ventricular diastole distally, and as the atriums start to fill up, that'll be enough pressure to open the atrioventricular valve will open. And then we're going to start our cycle again. So at this stage here, where we're going to relax and we're into our diastole phase, or distally phase. So let's have a look at those stages again then. So we have the atrium walls going to go contract, so we've got atrial systole. Then we have those AV valves are closed at the end of systole for the atrials, where we then have our ventricular systole. So blood is forced up and out of the heart, and as it does that, it pushes back slightly on the atrium wall, which causes that little bit of a peak you see on the graphs to do the pressure in the atriums. But ultimately, blood's taken out of the heart, and as it's being pushed out into the aorta, if the pressure becomes high enough, it'll open that semilunar valve in the aorta, and blood will travel out. And then as the blood pressure decreases, as the ventricular systole comes to an end, and blood is taken away in the aorta, the aorta blood is higher pressure than in the ventricles, so it will fall back due to gravity on those semilunar valves. And as we know, those semilunar valves are kind of this cup shape, so as the blood falls back on it, it will close that valve, and then the blood will be taken away in the aorta. And then we have a small pause, which is diastole or distally, and then we have our next phase begins again, the cardiac cycle, which would be your atrial walls then contract, etc., etc. So we can measure how long this cardiac cycle is by using a graph like this, because we can go from one point to the next. So for example, you could measure how long is the time from, say, the peak of one ventricular systole to the next, or how long is it between, say, the end of atrial systole to the end of another atrial systole. So this repeating pattern is very useful for things like time, which is normally measured in milliseconds. We can also learn some things about the pressure, which is often measured in milligrams per millimeters of mercury, and it will also tell us about the cardiac cycle. So make sure you're happy with what we've done today, and then ask some questions if you're not.